Hello, welcome to Tom's Hardware, the podcast for May 28th, already the end of May. Wow. Where is the year going? My name's Les Pounder, Associate Editor. With me is Matt Venn, an old friend of mine from the old days of Raspberry Pi.
Hi.
Hi, Matt. How's it going, mate?
Yeah, good. Good to catch up with you a few weeks ago when you mentioned this. It's been the first time we spoke in probably quite a few years, right?
A long time, yeah. So, bit of background. Matt and I used to do Raspberry Pi courses nearly a decade ago. Is it nearly a decade? Yes, it is.
It was right at the beginning with the Raspberry Pis when it still had the composite video out, those first boards. And they didn't have the screw holes either.
Yeah. Pete Lomas's original design. I remember that, yeah. And we had that big networking kit in a suitcase that we used to travel around the UK with.
Yeah, and loads of laptops.
Yeah, so we used to use SSH and VNC to do all the Raspberry Pi courses back then, before portable screens were even a cheap thing. But Matt these days has gone on to bigger and better things, and I'm going to let Matt explain what he does really. So Matt, come on, tell us all about yourself, mate.
Yeah, I wouldn't say bigger or better. I'd say smaller and crapper. So yeah, I'm into microelectronics and semiconductors now. So that's why it's smaller, and definitely compared to the kind of silicon that Raspberry Pi is turning out these days, which I think is a really interesting turn of events for them. The GPIO chip that they've done, the type of chips that I'm making are like super basic. I'm more involved in. It's kind of like what we were doing, Les, with enabling people to do their own stuff. So
yeah.
A big part of those Raspberry Pi workshops were coming up with kind of 10 example projects, something where you could like press a button, a light would come on, or a motor would turn, or it would send a tweet or whatever. And then the teachers who were working with would like build these machines or these applications by connecting stuff together. And it's kind of a similar thing for me now. So I'm working on very simple semiconductor projects where people build their first custom microchips.
Awesome. So how do you build your very first microchip? So I know about an Arduino. I can program an Arduino, but I don't think right now in my head I could sit there and program my own custom chip. How would I get started?
Yeah, good question. So it's worth probably dividing chip design into two parts.
Mm-hmm.
One side is digital chips and one side is analog chips. And you need both to make a useful chip, really. But digital offers some advantages. The abstraction of the digital world and everything being just ones and zeros does make things a lot easier. And the way we typically start people off is doing a graphical drawing program. So you draw out your logic gates. So I don't know if you remember, maybe you covered this in school, having an AND gate or an OR gate or a NOT gate. Yeah. So with an AND gate, you've got to put two inputs in usually, and they've both got to be high, and then the output goes high. And if one or the other of those or both inputs is low, then the output is low. So you build a circuit by connecting up these little gates so that it does something like the secret code unlocks the door, and you've got to only when you get the inputs exactly right does the light turn on, for example.
That's awesome. So you're designing this in an application on your computer. What would you use for that? What's the common tool?
Well, one of the things that we're doing a lot of is working with people that are, I mean, just to take a step back, like chip design has traditionally been something that hardly anyone gets to do because it's extremely expensive to make a chip. And the software tools are very expensive to rent. They're all like, you pay a subscription to use them in the order of hundreds of thousands to millions per year per person. and then getting a chip actually manufactured is often like hundreds of thousands to millions as well.
Yeah.
So normally people don't get to mess around and play with those things. And we're one of the aims that we've got is to open it up and lower the barriers for more people to get involved, a bit like Arduino did with microcontrollers.
Yeah.
And one of the things that you remember from the Raspberry Pi workshop is we brought all our suitcases full of laptops because it was such a pain for people to even install something like VNC Viewer or an SSH connection. There would always be somebody where they couldn't get the software installed for some reason.
Yep.
So we tried to have like one route into chip design is through the web browser. So this tool that we start off with is called Walkway. Maybe if you share my screen, I can give you a quick demo.
Yeah. There you go.
So if you're interested in, if anyone watching this is interested in getting started, then one of the websites to check out is called tinytapeout.com. I'll talk a bit more about that later on. But we have like a digital design guide, and then there's a getting started with our digital design tool, which is called Walkway. And then I can open up this here, and this is going to now open in the web browser. So everything in the middle here is what our chip is going to be. So this is an extremely simple chip at the moment. It's got four of these inverters.
Yeah.
And we can add more down here at the bottom. There's the gates that we've got, like I mentioned earlier, an AND gate. So let's delete these and wire up another couple.
This is awesome. I've used Walkway before, but I've used it to just emulate a Pico or an Arduino or something. Never knew it could do
that's what it was for. And I'm collaborating with Uri Shaked, who's the author of this tool. And we added these logic gates in, and added a little bit of extra functionality. So this is in like drawing mode, and then I can put it into simulation mode.
Yeah.
And now you see over here, I've got these. The 0 and 1 bits are off, but 2 bits and 3 bits are on. And over here, they're all off. So if I turn 3 and 4 on, you see these two go off now because they're still going through these inverters.
Yeah.
And with that AND gate, I have to turn them both on to get that first pin, that first segment to come on. So this is how we get started with people who are just beginning. And you can do like fairly complicated projects. Maybe I will, if we go back to Tiny Tapeout, we have all the chips that we've made listed here for people to get inspiration. I think maybe here we've got like here's one, Worm in a Maze. This is like a simple animation project. Whoa, look at that. Maybe not so simple.
Yeah, I love that. Simple. What?
Yeah.
That's like a tube.
Okay. So this is Worm in a Maze. You see the worm, and it's going through the maze. So some of these Walkway projects do like little animations, and this is like probably the most logic you would ever want to draw in Walkway because it quickly gets out of hand, as you can see. There's quite a lot of stuff going on here. But that's how we get people started, using Walkway, drawing in the browser. And when people have got a bit of programming experience, like you said, Arduino, and you're used to writing, here we've got the Arduino code on the left.
Yeah.
People are used to writing things in a sequence. And that's one of the principles of programming, is the idea of sequence. But with hardware design, it's much more like a website design. So you create all these objects and then you wire them together.
Yeah.
But then when you run it, it all runs at once. It's a circuit. It's hardware. It's not executing a sequence of instructions. if you want a sequence in hardware, then the first thing you have to build is a counter so that it can count up and create the sequence for you. Otherwise, everything always all happens at once, like components on a breadboard.
Yeah, okay, yeah. That is very
So
cool.
that's the first step. And then the next step is you go to, let me open up a set of slides I've got prepared. Here's an example, another example of a simple walkway project. We have we use GitHub Actions. Have you heard of GitHub Actions?
I have, yeah. I've never used them, heard of them.
Yeah. They're very, very convenient things. So here's an example of like a slightly more complicated project. So once you using like more than 20 or 40 gates, you typically switch to what's called a hardware description language, and this one is called Verilog.
Yeah.
Where instead of drawing everything out, you define things. So it's a bit like HTML instead of Paint. So
yeah,
you're still saying, create me a flip-flop here, create me an adder here, create me something that can compare two signals here, and they're all being created and joined together with wires. There's no it looks a bit like C, but it's not sequence. It's a description.
Yeah.
And then we have these actions, and the GDS action. GDS is like the Gerber files that you send to a PCB factory, but for making a chip, the files are much more complicated. They're much bigger. There's usually like 50 layers, and we have an action that installs the tools needed to convert the thing that we made in Walkway and convert that to the GDS file that we need to send to the factory, and then it looks more like this. So this is for a more complicated design. There's more things going on here, but if I turn off each one of these little blocks is one of these AND gates or OR gates or registers.
Yeah.
And then they're all wired together like this into this block. And then that block is the thing that we send to the factory to get manufactured, along with a lot of other little blocks. So that magic all happens inside GitHub Actions. And the two of those things together, Walkway and the GitHub Actions, or Verilog and the GitHub Actions, is how you create the files you need to make your own custom chip.
That is damn impressive. I didn't realize it was all in the browser. I thought you'd be using separate applications and just sort of having a workflow where you go from one application to the next. But this has blown my mind, I'll be honest.
Yeah, once you get into it more, you typically do download the applications and run them on your computer.
Yeah.
But to get started, doing everything in the cloud is a lot easier, and like especially for a workshop with young people or people who are just doing their first designs, we typically do everything in the browser.
That's damn impressive. So you've got this now, so you send it off to be fabricated. What comes back to you? Is it just a chip, or is it a chip on a dev board with breakouts, or is it something else?
I love this auto rotate thing. Let me also just say that I did like an hour-long webinar with the IEEE Solid State Circuit Society called Getting Started with Open Source Silicon. And that is on their YouTube channel. I'll just send that to you.
Yep, send it in the chat to me.
In the private chat, so you can share that on the channel. So another important thing that happens is let's maybe go to Tiny Tapeout 6. No, let's keep on Tiny Tapeout 7. Why not? So Tiny Tapeout 7 is the shuttle that's open at the moment.
Yeah.
So if anyone out there is super enthusiastic, you've got 4 days to join the next shuttle. And this will be our 7th chip. We sent Tiny Tapeout 6 off to the factory at the end of April.
Yeah.
And one way that we get the cost down is we're using an old technology where the chips are, you get 100 chips for $10,000. And then what we do is each of those tiny designs, like I showed you earlier, that design.
Yeah.
That's like one of these little squares here. And we can put up to 512 of those on one chip. Now, some of these designs are much bigger. Like this one at the bottom is a Linux-capable RISC-V CPU. Very complicated project. But then we also have like a single project here. This one looks like a Walkway project. And then we bond all of those together into this one big chip, send that off. And then what they return to us is a chip. Let me see. Do I have a picture? There we go. And like a normal kind of QFN chip. So
yeah,
they do the manufacturing. The wafer gets sliced up into lots of little dies, they're called. And then the dies are put into a lead frame. And then the lead frames are bonded into these QFNs. And then we get sent 100 of these. And if I hold up on my camera, if you can full screen my camera, just wait for the autofocus. That's one of our chips.
Wow.
So then on that chip, we have the few hundred designs.
Yeah.
And then we send everybody who wanted a PCB their design and all the other people's designs. That's a really cool thing. So you get your design, but you also get everybody else's design on that dev board. Yeah.
Very cool.
So yeah, we make the dev board and we manufacture the dev board and then we send out the dev board.
That's brilliant. So that's a demo board in your hand there. Am I right in assuming you've got something Raspberry Pi related on that demo board?
Yeah, so this is the older version. So when we first started the project, I don't know if you remember this, Les, but I always do this thing where my first version is like a really crappy version, the minimum viable product, I call it, because I used to be a perfectionist and I would build a project out until I thought it was perfect before I shared it with the world. And I realized afterwards that's not a very good use of time and energy, because often stuff that I thought was really cool, other people think's rubbish. So I switched to a different methodology where you make the crap version, share that with the world, and if people are excited about the crap version, then the project's got legs and it's worth doing a good version. So this first version put all the chips in a long line, and all the little projects in a long line, and the data was sent from one to the other all the way through, and that made the project very slow. And then what we did with after the third one, we switched to a system which was much, much faster. So that lets you do projects like video and audio much, much more easily. And then we switched to this new dev board. I'll just hold it up here. It's got like a bit more stuff on there. And nice. On this board, we have the RP2040 chip.
Brilliant. So what's the RP2040's job in that case?
Yeah. So on the old one, you selected which project you wanted to be active using these dip switches here.
Yeah.
So if you wanted project like 255, you would turn on all of them on. And if you wanted project 0, you'd turn them all off. And so that used up 8 pins of the ASIC. And with the ASIC, you've only got like 35 pins that you can use.
Yeah.
Maybe you can share my screen again.
Yeah.
Let me see if I can find a picture of the pad frame. It's maybe a bit difficult to see here. I can just and I guess here on this is a decap, so this is like a chip where we have the layers cut off, and then you can see kind of inside the silicon a bit. Yeah. And each one of these is one of the pads that can have a wire attached to it. And then this space inside here is where we control what we put our projects in. This is my first chip that I made in 2021. And yeah, so we only had like 40 of these pins available, and then some of them were used for other things. So we only had like 30, and then I burnt 8 of them on the project select switch. So that meant you only had 8 ins and 8 outs. So it was like it was very limited, and it was very slow. Mm-hmm. But we still had a lot of people that were interested. We put maybe like 300 or 400 designs on the first 3 tiny tape-out chips. And then when we did Tiny Tapeout 4, we switched to the fast mux, and we took those 8 pins that I had burnt for the project select and added them as extra IOs. But then how do you choose which projects you want to have enabled? So we have a serial enable now. So if you want to select project 255, something has got to wiggle that project select line 255 times. And we thought probably people didn't want to press a button 255 times. So instead we used the RP2040 and have a web interface. So if I can show you that now. So it only works with browsers that support web USB. Yeah. So connect to board. Okay, so now and this also needs to be. There we go. There we go. So in the new version of there's so much cool stuff in this project. I love it, and I'm just one of the people involved. So it's definitely way cooler now. There's lots more people involved, and one of the projects. Can I just go back here? I think project 0. I don't know where that one is. Is the ROM, chip ROM. So this is a cool project from Uri. It also uses a GitHub action, and it takes some text specified what the chip is, and then it turns that into a read-only memory, and then adds that to the chip. And then when you connect to it with the command app, it reads out the ROM, knows what the chip is, and then it can tell you all the projects that you've got on the chip. Wow. So here I can select my VGA clock. Actually, I'm just going to change my camera now. Settings. There we go.
There you go. I'll just bring that in.
So got the my monitor here. Here's the dev board with the ASIC on it. I select the VGA clock. Select that. Set the clock speed to 31.5 megahertz, and then the time starts showing. And I've got this little extra add-on board here called the VGA clock P mod, and then that's got me my hours, minutes, and seconds adjust. Also, check this out. I've got acceleration on the buttons, and every minute it cycles the colors. So you get nice color cycling. So you do all of this through the command app. So it lets you explore the designs on the chip. If we go back to the app, there we go. And then so you can see which where the source is. You can click on that. All the projects are open source.
Yeah.
You've got the GDS and so forth, and then you've got the source. So if you want to find out how the clock works, how does it read the buttons, how does the acceleration work, all this kind of stuff, then you've got all the source code there. Then there's the interact that lets you send. So at the moment the buttons are happening externally, but if I turn this on here, now I can control the buttons through the web app. You see the pin out. So if the person's been good and they've filled in the data sheet, then it will tell you what the pins do. And then we've also got the REPL. So that's a way that you can interact directly. If you're used to using the RP2040, one of the cool things about it is the MicroPython stuff. So then in here, you've got the shuttle. You've got a list of all the projects. You can look at what the IOs are.
Yeah.
I'm not a great expert. There we go. There's pin in 3. You can find out what mode the pins are in. You can read information. You can clock information in and out. You could write your own test bench and then run the test bench against the ASIC. And all of that's enabled by the RP2040.
That is really cool. That's a really cool use of the RP2040 to work with that chip.
Yeah. It's a really nice combination. And then the SDK is also built with a GitHub action. So when we make changes to that, you can that's the other thing I love about the RP2040 is you press and hold that boot button when you plug it in, then you just drag and drop the release from GitHub and you get the latest version of the firmware. So
is it a UF2 file?
Yeah.
Oh, brilliant.
So super nice, everything connected. The thing that we're working on next is, there's a couple of things. We've got one thing. We've got an FPGA board, and an FPGA bitstream GitHub action. So when you build your project, as well as generating the GDS file for the ASIC, you also get a bitstream for the FPGA.
Yeah.
And then you can plug that in instead of the ASIC. You can test your design on the FPGA straight away. And the other thing we want to do is enable the Commander app to work remotely. So you could test the chip. So if you share my screen again,
there you go.
If you're on Tiny Tapeout on one of these chips, you'd be able to go to like Tiny Tapeout 4, and as well as seeing what all the chips are, you would be able to play with one by connecting to it over the internet, enabling it via the Commander and playing with an ASIC that's sat connected to a Raspberry Pi in the office. That's not something we've got yet, but I think that would be really nice because that would also let you play with other people's designs without having to order a board or a chip.
That is really interesting. I'm already thinking of ideas. I saw one on your slides before about NeoPixels WS2812, and I thought, you could. It wouldn't be easy, but you could make your own NeoPixel controller of sorts, and having something that interacts with RP2040.
That was actually one of my very first ASIC projects. This one here is one that drives 8 WS2812 LEDs from an ASIC.
That's amazing. So is it a pre-programmed sequence it goes through, or is there some interactivity with it?
No, you load into it what you kind of write into the memory.
Yeah.
It's kind of interesting. This is the clock, and then you see actually that the WS2812 driver is bigger, and one reason is because it uses 24 flip-flops for each LED, and there's 8 LEDs, and flip-flops are the biggest standard cell, the biggest logic gate.
Yeah.
So it actually it stores quite a lot of memory. Well, I say quite a lot. It's like a few hundred registers. You set the colors of all the LEDs, and then it just sits there like banging out the codes to keep the colors how you want them.
That's interesting. Very interesting. So if you've got interested parties who want to get started in this, where do they go first of all to find out and to take the first steps?
Yeah, the first place is probably either Tiny Tapeout, and so we've got like the digital design guide, which is a getting started into digital design. We've got like a cool section on how do semiconductors work, which uses another tool that I made with Uri, and that's another web-based tool that basically shows you how the absolute fundamentals work. So how a MOSFET is created, and how when you increase the voltage, how it's like a voltage controlled resistor. Basically, you can control the amount of current you can source by putting the amount of voltage on this, and how that all changes, and what the cross section looks like, and then how you build that up into something like an inverter, a basic standard cell, and you see how when the voltage increases, the input switches from high to low. So that's all inside Tiny Tapeout, and then we have a community on the Discord. It's called Tiny Tapeout, and you can get to there via the website here. Join the fast and friendly conversations on the Discord. And then I also have I have like a more advanced course, which basically takes you through step by step, and also teaches Verilog, and it's a bit more detailed basically, but it's also it's $650, so it's quite a lot more expensive. It does include a free tape out though, so that's one thing we haven't mentioned is the price of this stuff. So if you want to just make a design and get that on the next chip, you can do that for as little as $50. Wow. So that's just one of these little tiles with your design on the next chip, but you wouldn't get a copy of that. It's just we would make it. If you actually want a copy of it, then it's $150, which is half price, and that's because we've got sponsored by eFabless, which is the company that basically offers the service, that sells us the 100 chips for $10,000. So for like, it's like an early bird deal. For the first 100 chips, they're only $150 each, and then it goes up to 300 each. So then for the early bird price, you get the chip, your design, and a demo board with a free RP2040.
Brilliant. It's an interesting area.
Never been easier, never been more affordable.
It certainly seems it, yeah. It's something I've never really looked into. So, you know my background. It's microcontrollers and microprocessors. So Raspberry Pis, Arduinos, that sort of thing. I've never really gone into chip design itself. I've messed around with circuits and built on a breadboard, but never gone down to this level. We're going to know the absolute level of everything, that most smallest point you can get to design it all.
Yeah,
and it's super interesting.
Yeah, it is. Yeah, and it keeps on getting more interesting. So if maybe we just like end up with this project, which is a design by the principal IC scientist for Nordic Semiconductor, who's also an open source silicon enthusiast. And you can see how this one looks quite a lot different to the designs I've showed you so far.
Yeah.
And that's because it's an analog mixed signal design. And it's an 8-bit analog to digital converter. So this is there we go. That's so cool. When you start getting really good, you combine and like I mentioned, we split chip design up into two halves, the analog and the digital. And when you get really good, you combine them both, and there's a ton of value there. Like, so Tiny Tapeout is, to start with, aiming really for education, where the open source tools and the open source PDK, the libraries you need, are really a game changer for doing training. But a company like Nordic Semi, they did all their chips until about 2 years ago on 130 nanometers, which is this like old 20-year-old process. So there's still a lot of value that you can get, but a lot of that value is locked up in the combination of analog and digital. So one of the things that I was super excited about for Tiny Tapeout 6 and onwards is we now support designs like this, mixed signal designs. So I'm working on a new course, the analog course. I'm going to just drop you the link, if you don't mind sharing that as well in the
send it over.
If people are interested in getting on the wait list for the analog course, then it's going to be like a step-by-step guide, a bit like the 0 to ASIC digital course, but focused on analog and mixed signal. So we just run the first 2 beta groups, and we've been taping out on Tiny Tapeout 6 and 7, some simple, much simpler than this. This is like a real pro design by a real professional. But it's, really exciting for me to see people who with much greater skill than me making these really incredible designs.
It's awesome. Well, talking of designs, Bailey in the chat's asked this question. Are there any projects for emulating IBM standard 8088 and 286 systems? I mean, could that be done?
Good question. So I'll just go to Tiny Tapeout and type in 8088. We'll see if anyone's done anything. There's an 8080 CPU that was recently taped out by Emily on Tiny Tapeout 6. So
Wow.
I would say use the search box and find these things out. I think the Pentium was done on 130 nanometers, but the Pentium was like 50 experienced engineers working for a year on a massive project together. So it might be possible on the technology we have available, but it would be an enormous undertaking to build a project like that. I would probably a good way to do it is to go to these runs, kind of have a look at, here's like a medium-sized complicated project. Here's a much more complicated project because it's usually so big. And then look at some simple projects, and that will kind of show you what the kinds of things that people can do. Good way of getting started.
Yeah, definitely. That's really cool. So we talked a hell of a lot about hardware tonight. Now, you mentioned before that we started the show that there's some software elements to do with Python. You mentioned Pat for this.
Yeah, I saw Pat joined. I don't know how long we've got.
We can go into extra time. We're okay.
All right. Why don't you invite Pat on then? If he's here.
Here he is.
Go. Hey, Pat.
Hello.
Hi, Pat. How's it going?
Pretty good. Yourself?
That's bad. Nice to meet you.
Nice to meet you. I'm sorry I'm late. I was actually on another podcast and it went kind of long.
Back to back.
Pat's in demand.
Pat's in demand. Good news is everything was set up, the camera. So cool.
Excellent. So Pat, what's your involvement in all of this?
The short version is I started Matt's course a little while ago, and then I kind of fell in love with the whole concept, and I bugged him until he let me help out. So I actually got one of the hats. Was this in Berlin? I can't remember, Berlin or Los Angeles or wherever, for doing the workshop. So I've been helping out on Tiny Tapeout on 0 to ASIC. I designed the demo boards. So this thing that goes in the back, the carrier as well, I guess. So this is the Tiny Tapeout demo board. I don't know if you've talked about it yet.
We have, yes.
Okay, so great. So
Lovely board.
that's one of the things I do is basically help out on the support hardware, and yeah, and talk about it a lot.
Wow. So the board itself, the what you've done, yeah, try and get the words out. The board you've designed there. How did you design it? What applications did you use? Was it anything to do with Walkway and what we've seen tonight, or was it something more like KiCad or something else like that?
The demo boards.
Demo
This
board,
is
yeah.
basically all KiCad. So KiCad is my workhorse. It's what I do in to keep the lights on is make circuits, and I just use KiCad all the time. So yeah, KiCad for that. Eclipse to write the SDK for the RP2040 that's on it. And that's pretty much it. Of course, as part of the game, I get to play with making circuits. So I also made a super basic ADC, nothing like that one we were looking at for Tiny Tapeout 6.
That is awesome. It's wonderful to see all the open source software working together. So we've seen Walkway today. We've seen GitHub Actions, KiCad, all of these fantastic tools which are free and open source, and we can do what we want and help each other with them.
It's nuts. And when you have the infrastructure, all the tooling being free and open source, I'm interacting. It's live right now, magic and stuff. When you're doing analog design, Tim Edwards is available. He's on the open source Slack thing. XSchem, Stefan Schippers, he's available. We can actually interact with these people. And then you have the user level where the people who are doing these projects on the Tiny Tapeout chips, they're all on the Discord and they're all exchanging. Some of them have 20 years of experience, some of them are just like, I have no idea. And everybody's helping each other out. And then when the projects are released, they're all open. So you can leverage those. My ADC is actually using Matt's R2R DAC. And so I did, I needed a DAC. I had done a comparator. I saw he had done the DAC. I just stuck it in there. So the cross-pollination isn't insane with open source.
That's wonderful to hear. I'm long been a fan of open source, and long may it continue. It's fantastic stuff. I'm also very envious of behind you, your background, sir. That is a fantastic lab you've got there. That's just...
It is. I am so lucky. It took me a little while to build this up, but boy, this is a playground that I would have been envious of of 10 years ago. Now I get to play here every day.
Yeah, I know you're making chips that you can do whatever you want with them. Do fantastic work with them.
It's super.
Brilliant. Well, thank you. Let's just go back to... There we go. All three of us are back. Matt's wearing his understated bling there, I see.
Yeah. Somehow the yellow hat works on him. It just totally does not on me. So I keep it as a decoration.
I'm not really sure if it works on me either, but I just like wearing it.
Oh, maybe we're just used to it.
Yeah, that's it. I just like...
You can always find Matt in a conference. You just kind of look around, boop, he's there. Let's go.
Yep, definitely. So, Pat, if anyone wants to find out about you and your work and whatever they want to know about you, what's the best place to find you?
The two places in relation to this would be, the Tiny Tapeout Discord is one good place, but I also have a YouTube channel where I just randomly put stuff that I have discovered that I think would be of interest or useful to others. So that would be youtube.com, Psychogenic Technologies. I just put out a video about the analog design process, at least from my point of view. So you could check that out.
Brilliant. If you've got a link and you want to put it in the private chat, I can chuck it out into the chat now.
Let me do that.
Why not?
I'm ahead of you. I was already pasting it in there. And I also want to say Pat's videos are great. So,
thank you.
And he's done loads of KiCad stuff, and he's not so ASIC obsessed as I am.
Yeah, not exactly. I alternate between the pick and place, the KiCad, and the ASICs, and I just kind of circle around that.
There we go. It's in the chat.
Cool.
Thank you very much. Well, we've gone into extra time, but thank you very much, Pat, for coming on at the last minute. It was fantastic to talk to you about this. And Matt, fantastic to talk to you again, sir. It's been a hell of a long time. Let's not make it too long next time.
Yeah.
But it's been brilliant. And I am super enthusiastic about this. Really think it'll be a great thing to play around with, especially now it's Walkway, which is something I've used before for Arduino stuff.
Yeah.
Oh.
Yeah. Well, see if you can put something together in the last 4 days, and I'll give you a free tile for Tiny Tapeout 7.
Yeah, you can do it.
You can do it.
I may be
We've done it
slightly
in 3
busy.
hours. A 3-hour workshop. People have put stuff on the tape outs. Oh, I see. You have a stack, and it's literal.
This is the stuff I've got to go through for review. This is all from Pine
You're
boards.
busy.
Oh yeah, this is all Raspberry Pi 5 PCIe boards for hard drives, so NVMe drives, AI, PCIe ports.
They're all different. That's great. Won't take any time at all.
It's good fun. I need to go through all these and play with them. So I'm afraid to say I will miss out on this occasion, but I will do something in the future. I'm very interested in it.
Anytime. Yeah.
Brilliant. Well, I'm going to thank you both for your time, lads.
Thanks for the invite.
Thank you for coming on. Appreciate that. We'll be back at the same time next week, 2 p.m. Eastern, 7 p.m. in the UK. Thank you very much. See you later.
Cheers.
Bye-bye.